quantum woo-woo, which is the old way we'd say it. I say we change it to quantum oo-woo. Mostly because it'll have a slightly higher page ranking for my video, but also because it's easier to pronounce. Go look up W-O-O, W-O-O, and see the explanation and the mythology of where the wording came from. It's kind of thin. Or we can just start over and just call it oo-woo. Google's quantum oo-woo chip, Willow, the multiverse of parallel universes and memes that was thrown on the wall like spaghetti to see if it would stick. Instead of discussing them plagiarizing themselves, let's move on. When quantum computing was first being proposed, there was conjecture that it could actually work by running calculations in multiple universes, according to the many worlds theory. That's a quote from some website, or maybe it was a Wikipedia page, or maybe it was the link from Wikipedia. Let's change it. When people were asked how quantum computing could work, they said that it's like running a many worlds interpretation of something by running it as if you were running it in multiple universes. We have a misquote happening from the get-go. Okay, let's move on. Yes, it's hard to understand the quantum oo-woo. Let's continue. Now, this is an implementation I'm going to talk about in a minute that has a special name for it that breaks a bunch of rules on how to make an acronym, by the way. Or if you're compacting two words together, what's that wording called? Let's move on. In order to decrease the sensitivity to charge noise while maintaining sufficient anharmonicity for selective qubit control, superconductors are capacitively shunted as transmission line shunted plasma oscillation qubits, or transmon. Transmon, transmission line shunted, transmon. Why am I bringing this up? This is something that's brought up on a Wikipedia page with a straight face as why it's called TRANSMON as transmission line shunted plasma oscillation qubits. That doesn't make transmon, does it? So, what is that really? We found out our equipment makes a bunch of noise, and it's sensitive to noise because it's operating on such an extremely submicroscopic scale that we have a huge amount of noise we have to interpret through to see what it's doing. Because even our test equipment has trouble finding out if it's there and figuring out what it's doing. But hey, it's totally viable as a commercial product for you to run a video game on. But I don't care that that's not the reasoning for it. I'm going to do that to mock this. What is this actually explaining? Capacitive shunting or other forms of shielding between two or more items is done because they're either producing enough, we'll call it noise, that they interfere with each other, or they're very sensitive to external noises, and you're using two of them to run the same process in one configuration and another, so you can compare the outputs to get a more reliable output with higher integrity. Does that sound like a system that's really easily vulnerable to bullshit happening? That's called transmon. Now we're going to go on with Google's implementation so far on the Wikipedia page of list of quantum processors, which doesn't explain why hypothetical, theoretical, or simulated processors are included. But let's move on, because it's photoshopped. Let's move on. 2017, Google creates, actually, their first quantum processor. It had no name to it. It was superconducting, because almost all of them are, so why are we bringing that up? And it did a lattice that created 20 qubits. and it had 99.5% fidelity. For comparison, the computer you're using has a reliability percentage of 100%. It has a mean time between failure of 5 years, meaning it will eventually make an error that's purely because of the hardware in 5 years. This was a process that, according to what little I'm allowed to look up, was a process test that took less than a picosecond, and it had a fidelity, which we're not getting explained, of 99.5%, or 0.5% not fidelity. Also, it was supposed to have a certain lattice arrangement, a grid, if you will, a matrix of individual components that make up the 20 qubits. They didn't explain what it was. They got one with slightly higher fidelity in the same year. Again, no name for it. It's a superconductor. And it had 49 qubits, but it was planned. But it was a 7x7 lattice. Planned? 2018 Bristlecone Supercomputer Chip used Transmon, which I've already explained, and it was a 6x12 lattice and was 72 qubits. And that was March 5th of 2018. 99% fidelity. You have a lower fidelity on something called readout. 99.9 fidelity, 99.9% fidelity, blah, blah, with 1 qubit. If you had 2 qubits, it was 99.4%, lower fidelity. We take 2 of them, have them do the same process, and we're getting lower fidelity. Fidelity isn't accuracy. I'm sure it's not almost exactly the same thing, and they should just say it fails more than 0.5% of the time during the test period, or less. Why? Again, your video card, which is probably outdated, might not have a single failure in 5 years. This was a test period. How did they test it? You don't need to know that. Let's move on. That was 2019. Google put out, instead of the Bristlecone, they put out the Sycamore Superconducting Transmon Chip. It was a 9x6 lattice of 53 effective out of 54 total qubits. And they didn't list the fidelity because, as you can figure out from that, one of the 54 qubits wasn't working. Let me see. 6 times 9, carry the 3, divide by 0. Yeah, that's 54, right? Yeah. Is that right? That 9 by 6 is like 10 times 6 minus 6. So, yeah, that's... Hey, that one before that was 20 qubits. Was that a 5x4 matrix? Or lattice? 12 by 6 lattice was 72 qubits. Carry the 3, divide by 0. Okay, we're getting some consistency. So, okay, now we're going to look at 2024 Google Willow Superconducting Transmon circuit. Now, remember I said in 2017 they had a 7x7 lattice at 49 qubits. Planned. This one is a 7x7 lattice of 49 effective qubits out of 105. And it had 99.965% fidelity. That's almost 99.97 fidelity with 1 qubit. They had 99.67% fidelity with 2 qubits, or almost 99.7% qubit fidelity for 2 qubits. And that was December 9th of 2024. Now, I want to point out something here. Very, very, very odd here. At that effective qubit of 49, okay, and 7x7 lattice from 2017, yeah, that matches. And at 99.67 versus 99.7% fidelity for 2 qubits, that matches the no-name superconductor that was planned in 2017 They just increased it from 49 to 105 until they could get the percentage up for fidelity with 1 qubit. That means they took 2 of the no-name chips from 2017, slapped them together in parallel mode to implement, again, what is it called again? Transmon mode. But instead of 49 plus 49 equals not 105, they had to add extras to get the percentage up higher. And that was what was put out. How are these tested? Okay, this is Google we're talking about. D-Wave will tolerate you looking at their data. Google will tolerate you looking at your data. It's not smoke screens or anything. Okay, I'm going to talk about how to test for perpetual motion machines, but let's read some news reports on that day. Google's Willow quantum chip breakthrough with a questionable benchmark methodology hiding information. The day after, Google claims quantum computing milestone, but the tech can't solve any real-world problems. Okay. Let's digress a bit. Imagine I'm holding the end of a extension cord. Sit for a minute. I chop off the end of it, and it's just the end of the extension cord. I'm not even trying to do anything nice. It's just brand new so I can do something. I then proceed to make the thing into a cube that's exactly 10 centimeters by 10 centimeters by 10 centimeters. So it contains a large number of centimeters cubic of space. It's a definitive number, and it has a 120 volt outlet sticking out of the dead middle of it, and I'm going to call it my power box. Okay, and it's about 4 inches by 4 inches by 4 inches. Just go with it. Okay, I make it into a cube by taking that chunk of a power cord, which I've completely pulled all the wires out of. I've totally removed them, and I just shove it into its dead level to where you can't tell that it was just an extension cord that I put a big blob of flex seal around. Okay, pop it out of the mold. Perpetual motion machine has a bunch of special conditions because I'm doing not woo-woo pedaling, but ooh-woo pedaling. I'm a cutesy little boy. And I dare you to prove it doesn't produce power, but I just keep coming up with excuses why I'm not going to let you take it apart or test it fully. Can't touch it, can't put a meter on it, because it's worth $1 trillion, but for some reason, even though I'm saying it totally works, I won't demonstrate it. And I want investor money. Why am I bringing this up? There's a certain maximum capacity with conventional batteries for the highest power density for a battery. And if you simply start with its 10 centimeters cube, 10 centimeter across cube, or 4 inch across cube of material, just say, let's get a battery that's exactly that capacity with raw terminals. Let's charge it up according to recommended specifications and then see what its maximum energy storage capacity is. Now let's look up the theoretical maximum capacity. I'll have a link below on Wikipedia for maximum storage density. Does your device do better than a battery? The immediate response from someone who's lying to you about the perpetual motion machine or whatever is they'll redefine what it means, but they won't actually just plug in a meter and test the fucking thing. Plug in a hairdryer, if it's a 120 volt plug, and run it at 1500 watts and see how long it takes till it dies. Well, that's the beauty of it. And then they go off on a philosophical tangent about how it runs off unicorn farts instead of testing it. The test procedure that was used by Google that was a benchmark that was questionable was simulating on a normal computer. That's why this was a big deal. It's not a multiverse or parallel universe. It's not some secret tech that baffles scientists. I'll put that in the title of the video. It didn't fucking work. It was a scam. Every one of these I look up ends up being a scam. Because, same thing with the brick being a battery. Take the same number of Bitcoin mining equipment in volume and how much it weighs compared to your supercomputer. Does the Bitcoin miner do better? Yes, go away and get off the fucking internet. Why don't we do this test to everybody? It's a basic go, no go, anti-bullshit test. Nobody does. Thanks for watching. Have a good day. Good luck with that. Bye.